Hi everyone! In this video I want to show you a project I was working on for some time. The circuit you see is called Interactive Controller for Brushless Motors, and the main objective is to be able to change motor controller parameters on the fly. Some of you may recognize this power stage from one of my previous videos. It's based on Allegro Microsystems A4960 sensorless brushless DC motor controller IC. A4960 is very flexible, but it won't run the motor by itself. The microchip PIC24KM series microcontroller is used to set A4960 parameters, start, stop, change direction of rotation, and also read back motor speed and other runtime data. The controller drives this dummy load I made out of two identical brushless motors coupled together. The motor on the right receives power, and the motor on the left has its windings shorted together to provide braking. Essentially, it generates electricity and wires act as a load. Finally, all interactions with the controller are carried out via serial link, and this USB to serial converter connects the circuit to a PC terminal. All configuration registers of A4960 are accessible from terminal window. The navigation is quite simple. If you want to get into certain menu, use a corresponding digit key on the keyboard. For example, this menu controls run parameters. You can change off time, phase advance, back EMF, etc. You can also execute standard run direction and brake commands. To start the motor, I first press 7 to select run, and then press W to change the run bit from 0 to 1. To stop the motor, I press W again to change the run bit back to 0. If I want to change direction of rotation, I first press 6 and then W, and start the motor again by switching to 7 and pressing W. Let's start the motor again and see what happens when I'm changing a runtime parameter. For this demonstration I will be using phase advance. First, I select it by pressing 2. Then, when I start changing the phase advance, you can see that the motor speed and sound are also changing. By cycling through all 4 possible values, I can estimate how this particular motor reacts to changes in phase advance under load. What's funny though, is that the sound change would make you think the motor is slowing down, when in fact it is accelerating. To stop the motor, I again select run, then set the run bit to 0. The code for PIC24 micro is written in C language and is built upon an open-source lightweight real-time framework called Quantum Platform, also known as QP. It provides essential real-time operating system services while being less resource-hungry than the full-blown RTOS. This is the website where you can learn more about the framework. And if you ever wanted to develop straightforward and reliable code, I suggest giving it a try. QP runs on many embedded platforms, including but not limited to ARM, PIC, and AVR, and there is even a package for Arduino. The link to the site is provided below the video. What you now see on the screen is the Quantum Modeler, also known as QM. It is a companion IDE to QP. Its primary purpose is to simplify coding and optimizing QP state machines. However, I'm using it to organize the whole project, meaning that I write and keep all my code inside QM. For example, this is my source files that are being fed to the compiler. They are auto-generated by QM from the elements above. All hardware-specific pieces are grouped under BSP, which means Board Support Package. This place under BSP contains all my interrupt handlers. And this is serial transmit ISR, which is coded just like standard ISR in microchip XC16 compiler for PIC24. Everything is neatly arranged in the same place, and if I need to, I can copy-paste elements between projects quite easily. Also, everything except BSP is platform independent, so I can migrate this code from PIC to AVR to ARM and back with little difficulty, only caring about hardware-specific BSP piece. The menu demonstrated earlier in a text terminal is actually coded like that. A QP state machine. The menu structure is clearly presented. Well, not so clear, it's still an alpha. And if I want to change order of the menus, it will be a simple matter of reattaching the transition arrow to another rectangle representing a certain state of the state machine. The data and functions that are internal to the console are grouped in one place. In QP, this is called active object, and to me it looks similar to a C++ class. This kind of project arrangement makes it self-describing. This allows me to switch back and forth between projects quickly. The structure of the project itself gives me hints about what's where, so that I don't need to memorize or recollect anything. This kind of project. I will be talking more about QP and QM in future videos when I start explaining the ICBM code in detail. I will also be making source code as well as QM model file available on GitHub. The link to the repo will be in its usual place below the video when the code is posted. If you would like to know more about the project, please leave a comment here on my site or in my Google Plus community, all linked below. See ya!